Hi, folks. Good morning. Thoroughly enjoyed the two talks in the morning. Thanks for those. A little bit about me. My name is Nuwan. I'm a developer myself. All right. Developer myself. Work in solutions architecture. Travel around US, around world. I'm from Sri Lanka. Interestingly, Sri Lanka is one of those small island countries in Indian Ocean. We have a major amount of Apache committers per capita. I think it's only second to US. The company I work for is the founders of Apache Web Services project. So if you work with Apache Axis, Axis 2, Sandesha, Synapse projects, you probably work with the group that I'm working with. I'm also a committer to Apache Synapse project, and Apache Web Services project. If you're familiar with SOAP stack, then probably you work with those projects. All right, so today I wanted to talk about a new programming language that myself and a couple of my friends working on. It's called Ballerina. So I'll try to explain why we did a new programming language, and we'll show a bunch of code samples, what you can use this language for, and things like that. So to explain the premise of why we did a language and why we need a new language and etc. If you think about it, today, all of us, if you're writing software, if you're writing systems, you are probably integrating APIs, probably integrating data sources, data services, etc., and creating your application. Today, you don't write your application from scratch. You try to integrate with different systems, different services across the cloud. Probably you're connecting with Salesforce, ServiceNow, Jira, GitHub, and all those systems that's hosted somewhere else. So your application today is a composition, essentially, right? So assuming that you agree with me there, we think that this amount of services, amount of APIs is exploding. The things that we can consume, like from Amazon, from Netflix, from all the different services, there's vast majority. So when you write an application, you want to consume all those things and make a rich application. So essentially, you're solving an integration problem. So what are those constructs? So you have functions. You have functions as services now. You have APIs, RESTful APIs predominantly, that has a contract, like a Swagger definition or something like that. Then you have data. Data in databases exposed as services. You call them data services, or now a fancy word like a data lake, and provide an endpoint for that data lake, etc. Then you have SaaS applications like Workday, Salesforce. If you are an enterprise engineer, enterprise software engineer, you're probably working with Salesforce, integrating with Salesforce, putting data into Salesforce, and things like that. And then you have there are legacy applications. You're probably interfacing with mainframes, etc. And then, of course, devices, right? So we are in an era of Internet of Services, so there are a bunch of IoT devices that you want to connect to and get data, get events, and process those streams, etc. So what we assume is that amount of these endpoints, functions, APIs are exploding, so you need to have a better way of integrating with these devices and APIs and functions. All right, so I assume that it means that you're trying to solve an integration problem. So what is an integration problem, right? So you have endpoints all over, and now you want to talk to these endpoints and get data, pass that data, store that data, and all that stuff. So when you are integrating, that means you are interacting with a distributed system, right? So if you are a programmer, if you have worked with distributed systems, there are inherent problems when you're dealing with distributed systems. It's not like you're writing a program in your own computer and moving it to production, you have to think about the network latency, transactions. If the network is not available, if the endpoint is not available, how do you handle those errors? How do you handle event streams and all that stuff? So these are the problems of the distributed system. So essentially, programming in a distributed system is complex. It's not like you're programming in your own on box in your own software program. So traditionally, there were a couple of ways people solve this problem, right? So if you've done these integrations, you've probably done it with programming languages like Java, Spring, JavaScript, Node.js, Golang, etc. If you are coming from a service-oriented architecture background, you probably known middleware products, term middleware, products like ESBs, enterprise service buses, BPEL, business process execution languages, and things like that. So those tools, what they do is they check those endpoints, they wire those endpoints together and give you a configuration language where you can write those wiring language code and provide you a nice transactional flow. You can do circuit breaking, you can handle resiliency of those endpoints, and etc. So what we found out is when the problem of endpoints are exploding, that there are a whole lot of APIs, whole lot of functions and services, etc., these two approaches really don't address that. So from one hand, you have ESBs, which are not really agile. You can't do a lot of testing work. You can't integrate it to a CI/CD pipeline and all that stuff. It's one software package or a middleware application where you install like a server product, and you put your configuration and you do integration. So it's we feel that it's not agile. And then, from the other hand, we have languages. Languages are very agile. You can write code. You can integrate it to CI/CD pipelines. You can test it, do integration testing, and all that stuff. But those are not integration native. Those doesn't have the native capabilities to do circuit breaking, native capabilities to handle JSON, XML kind of different payloads and transform them. They don't think of an application as a distributed systems application, for example. So there are those kind of aspects. So we think there is a gap, and we call this a integration gap. So Ballerina is a language to solve that problem. So if there's a purpose for all languages, for every language, if there's a purpose, the purpose of Ballerina is to address integration problems. So if you are writing an integration application, basically if you are connecting multiple endpoints, multiple APIs, functions, etc., Ballerina will be a very good solution for you. So that's the premise of the whole thing. Why the name Ballerina? Well, if you're familiar with integration and service-oriented architecture, you've came across two words, composition, orchestration, and choreography, right? Those two words are common in ballet as well. So that's the whole purpose of the name as well. All right, so so it's a full-fledged programming language. You can use it for all intentions and purposes, but it is really meant for integration-driven applications. All right, so I'll quickly do a hello world, and let's see. Is anybody keeping time? How much do I have? 10 minutes, sorry. So yeah, I'll quickly do a hello world, and I'll be there during lunch. So if there are questions or you want to have some hands-on stuff, we can discuss. All right. So I'll create a directory called demo. Oh. Can see? Yeah. So Ballerina is installed as a language in my machine. So if I do ballerina minus v. I have the 0.99 version. I'm inside the demo directory, so I'll create a project, ballerina init. We have language plugins for all popular IDEs. So if you do, so I'll use VS Code for this. So when you do initialization, you get a project structure .ballerina file, etc. So I'll create a new file, hello.bal. Bal is the extension. So I'll import ballerina HTTP. Then I'm creating a hello world service, right? So what I'm going to do is service hello on new HTTP listener, and the port will be 9090. And I'll create a resource called hi HTTP response equals new response set text payload hello Apache, and then I'm sending a message to the caller, respond with the rest. So there are some weird syntaxes if you are familiar with Java code, etc. So I'll try to explain what those are. So you can see that, so only real difference is this arrow sign. So we have this idea of the programmer has a, the programmer will know that you are in a distributed system because there is a caller and you are sending a message to the caller, and that is noted through this arrow. That's the whole idea of having arrow in the program. And that is the syntax difference to show that this language, or you're writing a distributed program. Another thing that I want to ask is, if you're writing an integration project or a distributed application, and if you want to communicate that to a friend, how do you document it? How do you document the interaction between two parties? What is the preferred way of documentation? Any developers? Anybody want to take it? How do you graphically document it? What is the most natural way? Like a UML diagram, maybe like a sequence diagram where you have a caller and an endpoint and you draw a line and show it, right? So with Ballerina, we will automatically create that for you. When you write the code, we will generate that sequence diagram for you. The language will automatically do that. So the syntax is created to draw that diagram itself. So it is self-documented integration language. That's another aspect of it. You can also do some code blocks, code modifications. So I can add new functions and things like that, and it will automatically create the code for you. But essentially, the idea here is when you write the integration project, the sequence diagram will follow it, and it is automatically documented. So now I'll run it. hello.bal. So it will automatically get compiled, and so I'll do a localhost 9090 hello hi, and that will say hello Apache. And the other important thing is, nowadays, when you write cloud-native applications, you want to deploy them as containers, maybe in a Kubernetes cluster, right? 5 minutes. So I'll quickly show you how that can be done. We have native library support for Docker, Kubernetes, and Helm kind of libraries. So I'll import, quickly I'll show you how you can deploy something into Kubernetes. And in Kubernetes, probably if you're familiar with it, there are some definitions that you can write, like the deployment and Kubernetes service. The deployment, service type. In the deployment, I have to give image. And as a name, I will give Ballerina hello. I'll use the same name in the service as well. All right, so those are all the annotations that you need. And now once you build this, so instead of running, I'll build it. I'll use my shell to do that. It's bigger. That automatically builds you a Docker container, a deployment, and a service. And we'll give you a Helm install command for you to deploy it into Kubernetes cluster. So I have a local Kubernetes deployment running in my machine, so I'll just install it, and it automatically get created. So if I do kubectl get service, you'll see the Ballerina hello is now running. So we'll also do minikube dashboard. That will show okay. Something is, probably there's a demo effect, so something is not quite running. I'll check what that is, but you got the idea. So, so some of these aspects are built into the language. So if you are building a modern day integration project, you can use Ballerina. You can write the Docker definitions, Kubernetes definition in the Ballerina itself. There's inbuilt language support. So if you're trying to build a complex, let's say, like a service chaining scenario, like in integration, that's a very common type of project. So I'll have that kind of a service composition. So I'll quickly show you that. So this is like a travel application that has a travel agency, hotel reservation, car rental, airline reservation. So the travel agency is the orchestrator. It calls multiple endpoints and do the reservation. So this is the code for the travel agency, and you can easily document it through the visual editor. So when you write the code, it automatically generates you this sequence flow, and you can communicate to your team, friends, about the integration project that you built. All right, so that's what I wanted to cover in a very high level for Ballerina, why we did the language, etc. I'll be around lunchtime. I can help you to set up Ballerina, maybe do a hands-on session if you're interested. And thank you.